Okay, so on router number 1 I am going to configure IP first. Config T interface F0/0 say no set, and IP address 12.1.1.1 255.255.255.0 exit interface loopback 1, and IP address is 1.1.1.1 255.255.255. Let's say 255. Okay, let me configure IP on router 2 also. Interface F0/0 no set, and IP address is 12.1.1.2 255. Interface loopback 1. Okay, I have configured the IP address on both router 1 and router 2. I am going to configure now BGP. Let me configure first iBGP. First of all, we will discuss indirectly connected neighborship in case of iBGP, then we will discuss eBGP. So let's say now on router number 1 I am using AS number 100 BGP AS number 100, and on router number 2 also I am running same AS number. So this is iBGP neighborship. On router number 1 I am going to say router BGP 100, and neighbor I am going to say neighbor 2.2.2.2, not 12.1.1.2, 2.2.2, because I am forming indirectly connected neighborship remote AS 100. Okay, and I will run same command on router number 2 also. Config T router BGP 100 and neighbor 1.1.1.1 and remote AS is 100. Now neighborship will not come up. Neighborship between router 1 and router 2 will not come up. Reason why neighborship will not come up, guys? See, if I will capture the link, start capturing. I'm waiting for open message. First BGP will form TCP connection, then only it is going to send open message. So first I am waiting for the TCP message. Now why routers are not sending TCP message? Why router 1 is not sending TCP message? Because here on router number 1 so run section BGP, I have defined neighbor is 2.2.2 and there is no route available for 2.2.2. So IP route. See, in the routing table, is route available? No. So router cannot send SYN message to 2.2.2 until and unless 2.2.2 is available in the routing table. Yes or no? So first of all, I have to inject 2.2.2 in the routing table of router 1, and I have to inject 1.1.1 in the routing table of router 2. And what will happen if I will configure default route, guys? If I will configure the default route, will it work? IP route 0.0.0 and 0.0.0 and next stop is 12.1.1.2. If I will configure default route, will router 1 send TCP message? No. So always keep in mind default route will not work in case of BGP. Okay, we cannot configure default route. BGP does not consider default route for indirect neighborship. So I am going to remove this default route configuration and I am going to manually say IP route. Let me configure the static route 2.2.2 and 255.255.255.255 and next hop IP address is 12.1.1.2. So now router 1 will install 2.2.2 in their routing table. You can see 2.2.2 is here. Okay, and see router 1 is sending SYN message as well. But when router 1 is sending SYN message, what is the source IP address? 12.1.1.1,
1.
right? But 12.1.1.1 is not neighbor of router 2. On router number 2 also I have defined neighbor is 1.1.1. So if it will send SYN message on address 2.2.2, this is SYN message. It is sending SYN message where source is 12.1.1.1 and destination is 2.2.2.2. So when router 1 will send this SYN message, router 2 will send reset message. Router 2 will send the reset message. Why? Why reset message? Because BGP is enabled on router number 2, but neighbor is 1.1.1, not 12.1.1.1. So it is receiving SYN message from 12.1.1.1. So it will send reset message. You can see router 2 is sending what? Reset message. 2.2.2 is sending reset message to 12.1.1.1. So here I need to run one command on router number 1. Actually I can tell to router 1 that whenever you will send any message to 2.2.2, you should update next hop. Sorry, you should update source address. So how you will tell? See, on router number 1, router BGP 100, and I am going to tell to router 2 that your neighbor 2.2.2, whenever you will send any message to this neighbor, always update source loopback 1. Source should be always what? The IP address of loopback 1. Once I will hit enter, see the next SYN message. Now source IP address is what in the SYN message? 1.1.1. Destination is 2.2.2. Destination is 2.2.2. But this time router 2 don't have root for 1.1.1. So how router 2 can send the SYN plus ACK message? Sorry, yes, SYN plus ACK message. Router 2 need to send SYN plus ACK message to 1.1.1, but root is not available on router number 1. So again, here in the capturing also you can see router 1 is sending SYN message and router 2 is sending which message? Router 2 is not sending any message, SYN message or SYN plus ACK message, because the root is not available. So on router number 2 also I have to configure one static route, IP route 1.1.1.1, 255.255.255.255, and next hop IP address 12.1.1.1. Okay. Now both routers are going to exchange, form TCP connection. See, SYN message of router 1, SYN plus ACK, and then ACK. Okay, and now here you can see the log message, BGP neighborship is up. Fine. So is there any problem, guys? Anyone have any problem in this? Now we can verify. So IP BGP summary 2.2.2.2 is neighbor. Okay. So how many command I need to run here? First of all, I have to define the route. I can configure dynamic routing or static routing. After that, I have to tell to router you should update source as a loopback. Okay. Now I am going to configure eBGP. Here I am going to configure BGP 200. Okay. So let me take you to R2. Say no router BGP 100. And route is already available. Do so IP root is already there for 1.1.1. I am going to configure BGP 200, router BGP 200, and neighbor 1.1.1.1, remote AS 100. And on router number 1 also I have to modify the configuration. On router number 1 I need to remove one command, router BGP 100, and do so run section BGP. I am going to remove this command neighbor 2.2.2 and remote AS 100, because the remote AS is 200. Okay, and say neighbor 2.2.2.2 and remote AS is 200. So IP BGP summary, still neighborship is idle. Clear IP BGP star soft in. So IP BGP summary, neighborship is, state is idle. We will discuss state as well, don't worry. But idle means there is some problem. Don't have neighborship, routers cannot exchange prefixes. So IP BGP summary, neighbor is idle 1.1.1. Why neighbor is idle? I have already run command update source loopback 1, but still neighborship is idle. So for that just you need to run one command, so IP BGP neighbor. If you will run this command guys, here in this output I just want to see one thing. Wait, where I can check TTL value. State is idle, okay, that is fine. Okay, here I am not able to see. See, external BGP neighbor not directly connected. You know there is one rule. In case of eBGP, directly connected rule is enable. In case of iBGP, directly connected rule is disable. Directly connected rule is enable means, you know, means we can form eBGP neighborship only with directly connected neighbor. We cannot form eBGP neighborship with indirectly connected neighbor in case of eBGP. In case of iBGP, by default this feature is disable. I forget to run command so BGP neighbor in case of iBGP, but later on I will show you. When I will configure iBGP, I will show you the output. Okay, and here let me do one thing. On router number 1, so TCP brief, let me check the TCP. So you can see guys, on router number 1 we don't have any TCP connection as well. And so IP BGP summary, we have one neighborship and neighbor is idle. You know the reason is I am going to down the interface F0/0 once. Interface F0/0 say shutdown. And say no shutdown again. Here we are not able to see BGP message, right? We are not able to see any message of BGP. Okay. Why we are not able to see BGP message? Open message. BGP open message should be here, right, in the capturing. Why it's not showing? Router BGP 100 and say no neighbor 2.2.2.2 and remote AS is 200. Do so run section BGP. I don't have any command. Do so IP BGP summary. I don't have any neighbor. And now I am going to say neighbor 2.2.2.2 and remote AS is 200. Here we are not able to see any message of BGP. You know the reason why we are not able to see any message? In case of iBGP, let me check the previous message. Oh, here I cannot say. See, let me do one thing. First, I am going to configure again iBGP. So let me remove this command from here. No, and say neighbor 2.2.2.2 and remote AS is again I am going to say 100. Okay. On router number 2 also router BGP 200. I am directly going to say no router BGP 200. Done. And router BGP 100 and neighbor is 1.1.1.1 whose remote AS is 100. Wait. What happened? 1.1.1 remote AS 100 and on router number 1 router BGP 100 router BGP 100 neighbor 2.2.2. So IP BGP summary neighbor is idle, so TCP brief, there is no TCP connection, and so IP route 12 is there, 1 is there, so IP interface brief exclude unassign, neighborship is fine here, IP address is fine, so IP interface brief exclude unassign. There is some problem on software. Okay, I can do one thing. From both router I am going to remove BGP. Say no router no router BGP 100 here, and on router number 1 also I am going to say no router BGP 100. So IP protocol, I don't have any protocol on router number 1, and so IP protocol, I don't have any protocol on router number 1 and 2. Let me configure BGP. Router BGP 100, neighbor 2.2.2.2, and remote AS is 100, and neighbor 2.2.2.2, update source loopback 1. And on router number 2, router BGP 100, neighbor 1.1.1.1, remote AS is 100, and neighbor 1.1.1.1, update source loopback 1. Okay, here is open message. Let me open this open message. Inside this open message, guys, if you will check TTL value, so what is TTL value here? 255. But in case of eBGP, TTL value will be 1. In case of eBGP, TTL value will be 1. So if router 1 will generate one open message with TTL value 1 from loopback interface, then router it will, when router 1 will, router 2 will receive it, TTL value will become what? 0 there, and it will discard it. It will discard the open message. That's why neighborship was not forming there. Here I am going to check. So IP BGP neighbor. Let me run this command here, and it is showing how many.
Yes, sir.
Yes.
255 outgoing.
Outgoing TTL is
255.
255. But in case of eBGP, outgoing TTL will be 1. In case of eBGP, TTL outgoing TTL value will be 1. So if TTL value will be 1, then indirect neighborship will not form. Yes or no? Then BGP cannot form indirect neighborship in case of eBGP because of TTL value. Am I right? Give me. It will send with TTL value 1 in case of eBGP. That's why in case of eBGP you will see I have to run one more command. Okay, again I am going to configure eBGP. On router number 1 I am going to remove one command, router BGP 100, say no neighbor 2.2.2.2, and remote AS is 100. Remote AS 100. I am going to say neighbor 2.2.2.2, and remote AS is 200. Done. On router number 2, let me say no router BGP 100, and router BGP 200, and neighbor is 1.1.1.1. Remote AS is 100. Okay, and neighbor 1.1.1.1, update source loopback 1 also. Okay, see, neighborship will not come up. Now it should be clear to you that why neighborship is not coming up, why neighborship is idle.
So, sir, here it means we need to manipulate TTL value.
Yes, here actually we have to disable the rule. That rule is what? Directly connected rule is enable in case of eBGP. Means we can form eBGP neighborship only with directly connected neighbor by default. By default, eBGP can be configured only on directly connected link. Okay. So here actually I need to run one command on router number 1. on router number 1, I will run one command, your neighbor 2.2.2.2 and disable connected check, this command. In the same way, I will run this command on router number 2 also, neighbor 1.1.1.1 and disable connected check. Now it is eBGP neighbors are not going to check the directly connected because rule is not disable. Okay, do so IP BGP neighbor. Here was the rule. Somewhere it was showing earlier, na? This one. And now you can see BGP do so IP BGP neighbor. Sorry, summary. Now neighborship is fine. So if you are configuring indirectly connected neighborship in eBGP, then you will disable this rule. If you are configuring indirectly connected iBGP neighbor, then you don't need to disable this rule. By default, this rule is disable. Fine. Is it clear? Now guys, see the reason why we are forming indirectly connected neighborship, and whenever we are forming indirectly connected neighborship, then why we should configure it with loopback interface. One benefit is, see, physical interface can goes down, but logical interface, loopback is a logical interface, so it will never goes down. Here I am going to use one more router, R3. Let's say between R1 and R3 I need to form BGP neighborship. Between R2 and R3 I need to form BGP neighborship. So I should configure neighborship with loopback interface or with physical interface. See now, scenario can be, if you will configure BGP neighborship between R1 and R3 directly. As you know, we can configure indirectly connected neighborship as well in BGP. So if I am configuring BGP neighborship between router 1 and router 3 by using physical interface, then if physical interface will goes down, then your neighborship will also goes down. Yes or no? Let's say there is one more path available between router 1 and router 3. Getting my point? R4 is there, and through R4 there are two paths between router 1 and router 3. So if you will configure BGP neighborship by using physical interface, and if R2 will goes down or your physical link will goes down, physical interface will goes down, BGP neighborship will goes down. But if you will configure BGP neighborship with loopback interface, so until and unless one path will be available between router 1 and router 3, your BGP neighborship will be up. Yes or no? If R3 will goes down, still my BGP neighborship will up, because 1.1.1 and 3.3.3 are reachable via router number 4. Getting my point? Getting my point, guys? So it's recommendation that whenever you are configuring indirectly connected BGP neighborship, you should configure through loopback interface. In case of directly connected neighbor, like if I am configuring neighborship between router 1 and router 2, then no problem, I should configure it through physical interface. But if indirectly I am configuring indirectly connected neighborship, then I should configure through loopback interface. Yes or no? Okay. Now see, from router number 2, I am going to remove BGP configuration. On router number 2, I am going to say no router BGP 200. No router BGP 200. And from router number 1 also I am going to remove one command, that is no neighbor 2.2.2.2 remote AS 200. I have removed this command. Do so run section BGP. How many command I have? Router BGP only. Okay, now I am going to configure R3. So let me configure one more IP address here. On R3 also I will configure BGP AS number what? 100. On router number 2 I am going to say interface f1/0 no cert and IP address. IP address will be 23.1.1.2 255.255.255.0. Done. After that go to R3. On R3 let me configure IP config T interface f0/0 no cert and IP address is 23.1.1.3 255.255.255. In real time also, you know, indirectly neighborship is also only important. Most of the time you will configure indirectly connected neighborship. Like here between router 1 and router 3 I want to exchange thousands of prefixes, and router 2 cannot handle thousands of prefixes. So I want to skip those prefixes on router number 2. So I will configure BGP neighborship directly between router 1 and router 3 to share those prefixes. Okay, here I am going to create one loopback interface loopback 1. IP address is 3.3.3.3 255.255.255.0 or say 255.255. Done. Now my requirement is very simple. If I want to configure BGP neighborship between 1.1.1 and 3.3.3, then 1.1.1 and 3.3.3 should be reachable with each other. This is only my requirement. So to make reachability between router 1.1.1 and 3.3.3, I can use any IGP protocol here, yes or no? I can configure IGP protocol, or I can configure what? Static routing. Okay, so you tell me guys which type of routing protocol you want to configure here between router 1 to make reachability between 1.1.1 and 3.3.3. Okay,
Sir,
yeah.
OSPF.
OSPF. First of all, let me configure BGP. On router number 1 also I am going to remove BGP configuration. No router BGP 100. And say router BGP 100. Neighbor is 3.3.3.3. Remote AS of neighbor is, let's say, 100. Neighbor 3.3.3.3. Update source loopback 1. Okay, that's it. After that on R3 router BGP 100 and neighbor 1.1.1.1 and remote AS is 100, neighbor 1.1.1.1, update source loopback 1. If you will not run this command update source loopback 1, then what will happen? Need of anyone? If I will not run this command update source loopback 1, then what problem I will face?
It will not form neighborship.
Why?
That, that I have no idea, sir. But I guess it is
Brother,
because of this
because
particular command.
whenever R3 will send any message of BGP, source will be the IP address of exit interface. Yes or no? Source will be 23.1.1.3. That's why I need to run this command. Okay, now is it clear?
Okay. So every okay for that next hop self type. So
Yes.
that particular egress exit ports IP address will be skipped, and this particular IP address will be used.
Okay. Now see, BGP neighborship is not coming up because 1.1.1 is not reachable with 3.3.3. So I can configure any IGP protocol here. I can use any IGP protocol. So let me configure OSPF. So on router number 1, router OSPF 1. First of all, let me remove a static routing configuration. Why there is a static routing configuration? Then say no IP route 2.2.2.2 and 255.255.255.255 and 12.1.1.2. I have removed the static routing configuration. From router number 2 also I am going to remove. Do so run section IP route. Say no to this. Okay, and let me configure now OSPF. Router OSPF 1, router ID, let's say 1.1.1, and then I can enable OSPF on interface fast ethernet 0/0, let's say IP OSPF 1 area 0, and interface loopback 1 IP OSPF 1 area 0. Done. Let me take you to R2. Router OSPF 1, router ID 2.2.2.2, exit interface F0/0, IP OSPF 1 area 0, exit interface F1/0, IP OSPF 1 area 0. Go to R3. Router OSPF 1, router ID 3.3.3.3, exit interface F0/0, IP OSPF 1 area 0, and interface loopback 1, IP OSPF 1 area 0. So IP route OSPF. What happened? So IP OSPF interface brief 0/0 OSPF is enabled, loopback 1 OSPF is enabled, ping 23.1.1.2 ping is also working on router number 2. So IP OSPF interface brief. So OSPF is running on fast ethernet 1/0. Now you can see OSPF neighborship is okay. So IP route OSPF. So IP route OSPF. Now 1.1.1 is here. Yes or no? And on router number 1, 3.3.3 should be there. So IP route OSPF 3.3.3 is here. Now you can see BGP neighborship is up. Okay. BGP neighborship is up. Okay. Now if I will create some loopback on router number 1, interface loopback 10, IP address 10.1.1.1 255.255.255.0, interface loopback 11, IP address is 10.1.2.1, loopback 12, IP address is 10.1. Let's say 3.0. I am going to advertise this network in BGP. Router BGP 100, network 10.1.1.0, and mask 255.255.255.0, network 10.1.2.0, network 10.1.3.0. So you can see router 2 don't have these prefixes. So IP router 2 don't have 10.1 prefix. Yes or no? But you can check on router number 3. So IP route BGP. So it have learned these prefix. Yes or no? So
Yes,
I
sir.
can exchange prefixes directly between router 1 and router 3 by skipping router 2. So till now we had discussed two problem. One, directly connected check rule and TTL value. For directly connected rule for eBGP and TTL value for eBGP. Yes or no? We have discussed these two problem in case of indirectly connected neighborship. See here again I have one problem. You know what problem I have? If on R3 I am using AS number 200, on router number 3 I am going to remove BGP 100. No router BGP 100 and router BGP 200 and neighbor is 1.1.1.1 and remote AS is 100. Okay, and neighbor 1.1.1 update source loopback 1. On router number 1 also I am going to modify some configuration. Router BGP 100 say no neighbor 2.2.2.2 and remote AS is 100. Okay, I'm going to say neighbor, sorry, 3.3.3 na, not 2.2.2, neighbor 3.3.3. Okay, and do so run section BGP or router BGP. So you can see I have not run any things command. These are the network command only. Okay, this time I am going to say neighbor 3.3.3.3 update source loopback 1. What happened? Oh, first neighbor remote AS is 200 and then neighbor 3.3.3.3 update source loopback 1. Done. Will neighborship come up or not? And guys, on router number 3 also, till then I am going to create some loopback, and before that please tell me why neighborship is not coming up.
Sir, due to TTL value, sir.
TTL value. So I can add one command here. Let me add that command also.
To
I'm going,
disable that particular rule.
okay, so router BGP 200 and neighbor 1.1.1 disable connected check. On router number 1 also I am going to run this command neighbor 3.3.3.3 disable connected check. Okay, so I have disabled the rule. Then also guys neighborship will not come up because as I told you that it is sending what TTL value 1 in case of eBGP neighborship. It is sending the open message with TTL value 1 in case of
eBGP.
eBGP. So on router number 3, first of all I am going to advertise 30 network 30.1.1.0 and mask is 255.255.255.0. Let me advertise 30.1.2.0 also and 30.1.3.0 also. Do so IP BGP, you can see BGP table. It have installed these prefixes. Okay, and on router number 1 do so IP BGP, it have installed these 10 prefixes. Okay, on router number 3 also these prefixes are going to become best soon. Now if you will check, you can see soon these prefixes will become best. .1.1.0 do so IP route 30.1.1.0, 2.0 and 3.0. 3.1 Okay, so this is my network ID. Okay, in the local routing table prefix is available. So IP BGP. Why these prefixes are not best? Only valid. Okay, we will discuss about this later. Before that, here you need to run one more command. You have to set the TTL value with neighbor 3.3.3.3 and eBGP multi-hop. So how many hop away your neighbor is? What should be the TTL value, guys? When router 1 need to send any
Two.
message to 3.3.3, what should be the TTL? 2.
Yes.
So I can set the TTL value 2 manually here. In the same way on router number 3 also, I will say neighbor 1.1.1.1 eBGP multi-hop 2. And now you will see neighborship will come up. You can see. Okay. And so IP BGP, now you can see it have received all 10 prefixes. Okay. And router 1 have received all 30 prefixes. Do so IP route BGP. All 30 prefixes is there. And on router number 3, do so IP route BGP. It have received these 10 prefixes. On router number 2, these prefixes are not available. So can I ping? Can router 1 ping 30.1.1.1, ping 30.1.1.1,
Yes.
and source is 10.1.1.1? Will ping work, guys? Ping will not work. So in real time, here we will configure MPLS. We will configure MPLS. On router number 1, I can say interface F0/0 IP MPLS. Sorry, MPLS IP. On router number 2, just I am configuring MPLS IP and interface F1/0 MPLS IP. And on router number 3, interface F0/0 MPLS IP. Now see. Okay, we will discuss about the ping later. Don't worry. Now you are able to see that I am able to exchange prefixes between router 1 and router 3 directly. Okay. Ping is not working because router 2 don't have route.
Okay.
Is it clear?
Sir, but I mean, why in real life MPLS will be configured, but like why using MPLS it will become reachable, sir?
Sorry, what?
Sir, here we have configured
MPLS.
OSPF first because
Okay.
yeah, we need to exchange particular prefixes, okay, from
Mm-hmm.
R1 and R3, between R1 and
Okay.
R3
Between
via
1 to
R2.
1.1 and 3.3.3.
Yes, yes, via
Okay.
R2. Okay, so for that we have configured OSPF, correct? And
Okay.
after that, when the neighborship was up for IBGP, it was okay. But when you configured eBGP, then for that you configure two rules. One is you disable that particular rule, and then configured a multi-hop command and give two as a multi-hop TTL value. Okay, and
Okay. And
still
one more thing, Nirav. When you are configuring the TTL value multi-hop 2, automatically rule will disable. So if you will not run that command, disable connected, then also it will work fine. Because if when I am configuring the TTL value 2, so automatically that rule will disable.
okay. So sir, but uh, this much is clear. But why, like when you are pinging, it is not able to ping. But why after configuring MPLS it will start pinging like
After configuring why pinging, it will start pinging. This is your question.
yeah. After configuring, so here you try to configure MPLS, basic MPLS,
So
correct?
MPLS is a label based forwarding, na? Routers will forward traffic on the basis of label, not on the basis of destination IP address. Now, without MPLS, if I am pinging 30.1.1.1 from 10.1.1.1, router 1 will check their routing table and it will forward traffic towards router 2. Router 2 will check their routing table, route is not available, so it will discard it. Yes or no? But in MPLS, forwarding will happen based on label. It will check the label. What label is coming in the traffic. On the basis of label, routers will take forwarding decision. I
Yes,
will
sir.
give
But
you basic overview of MPLS as well.
so, sir, basically, then we need to configure MPLS on R1, R2, R3, and
Hmm?
we have to also enable label distribution protocol, okay,
Okay,
LDP. And after that particular thing, it will start forwarding on the basis of labels, correct?
exactly.
So, this will be an example of MPBGP, I guess, MPLS BGP.
MPBGP is used to share 96 bits prefixes, that is VPN v4 prefix.
Okay, so here, okay, so this is not
Normal,
MPBGP,
like
correct?
normal BGP share 32 bits prefix, and we have one more types of prefix network, 96 bits prefix, that is VPN v4 prefix. So whenever you
Okay.
need to exchange VPN v4 prefixes, then you need to use MPBGP.
Okay. I thought here because we are using MPLS, so MPBGP, it might be okay.
No, 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 no,
Uh,
no, no.
fine.
Okay. I'm going to do one thing. Let me stop these devices, and I think I have one topology where I can configure these things. Okay, for that I think I have topology in EVNG.